We will next cover the static members in a class. Static members are the data and functions of a class, which are common to all objects of that class. A static member is accessible to every object created by a class, and can be referred from anywhere within a program. Static data in a class shares one copy of the data between all objects of the same class. It is automatically initialized when the first object is created. Its visibility is only within the class, but its lifetime is till the end of program. Static data members need to be defined outside the class with keyword static. Syntax for declaring a static data is static, data type, data name. Here is an example declaration of integer variable a, that is static in nature. Static function in a class gets access only to static members of the same class. Static functions can be accessed through their class name, without actually creating the object. A member function is declared using the keyword static. Syntax for declaring a static function is static, return type, function name, argument list. And this is an example of the static function, displayCount, which returns void, or nothing. Let's next write a program to understand how static data and static function are used in the program. Requirement is to define a class named test_static with static variable and static function. Using the function, increment value of variable by 1. Call the function by 2 objects of the class. Then call the function with direct reference to the class. So here we go with the program code. And this is the class named testStatic. In here, we declare 2 static members. We first declare the static integer variable count. It is defined outside the class as on line 15, where we inform the compiler that count, belonging to the class named test_static, is of type integer. Note the 2 colons, or the scope resolution operator, which is used to refer to the class name. This definition allocates memory space for variable count, and value 0 is auto-assigned to it. Note that usually, memory is allocated for data members of a class, only when its object is created. In the case of static variables, memory is allocated at the time of defining a variable. We next declare the function, displayCount, which is defined outside the class as in here. Program control shifts to line 18 of main program, where we create 2 objects of class, testStatic, with the names obj1 and obj2. On the next line in program code, we make a call to displayCount function of object1. So the displayCount function works. The count is increased by 1. As per statement on line 13, value of count is printed onto the output screen. In the code, program control shifts to line 20. We make a call to displayCount function of object2. The count is increased by 1. As per statement on line 13, value of count is printed to output screen. Program control then shifts to line 21, where we once again make a call to the displayCount function using inline function call, with the scope resolution operator, or the 2 colons. Count is increased by 1, and cout statement prints value of count onto the output screen. Program ends. So what did we learn here? Static variables of a class are common to all objects of the class, unlike ordinary variables, which have a lifetime only within each specific object. So static variables last until the end of a program, whereas ordinary variables last only within an object. Also, static functions don't need an object for being called. It works as inline function and can be directly invoked by referring to class name, using scope resolution operator, the 2 colons. We learned how to create and work with objects. Let's next learn how to create an array of objects. An array of objects is a collection of similar object variables occupying contiguous memory locations. Just as in simple arrays, each element of an object array is referred by its index number. It provides simple and convenient way to store tabular data. An array can be multidimensional depending upon the application requirement. When memory is allocated for an object array, data members are separate for each array element, but member functions are same, and are shared among all objects. Syntax for declaring single-dimension array is class name, array name, number of elements. For example, employee E2. This declaration creates 2 objects, E0 and E1, as an object array from the class named employee. Syntax for accessing public members of array elements is array name, element number.member name. For example, e0.getData function. This statement calls the getData function of first object, in the object array, named e. We will next write a program to understand how an array of objects can be handled. Program 55. Use an object array to input employee name, ID, salary of 2 employees and display them. Here is the program code, and this is the declaration for class named employee. It will hold 2 string variables, n for name of employee, and roll number. There is a variable to store floating number value for salary. All these are private access data members. We then have getData function with public access. It's defined outside the class, and is meant to fetch data from the user via keyboard entry. Similarly, we also have publicly accessed printData function, which is again defined outside the class. It's used to print the available data onto output screen. So next, the program control shifts to line 28 within the main function. An object array named E, of 2 objects, is created from the employee class. On next line, we declare integer variable I, and then count, which is initialized with 0. On line 30 we declare character variable, user choice. It is initialized with the letter Y. On line 31, we instruct to print on output screen the title, enter data for employees. It's printed on the screen. Then on line 32, we check if value in user choice is small letter y or capital letter Y. It is Y, and so program control now enters the while loop. On line 34, the getData function of object eCount, or E0, is invoked. It executes the getData function, which fetches data from the user via keyboard entry. It asks for employee name. I type in withAjitsaigal. It's stored to the variable n of object E0. The user is next prompted to enter employee number. I type A101. It's stored in variable roll_number of object E0. The user is next prompted to enter salary. I type 50,000. It's stored in variable salary of object E0. Then on line 17, a new line character is printed which brings the output pointer to next line. GetData function is over, and program control shifts to line 35. Here, the value of count is increased by 1, and it becomes 1. Then on line 36, the user is asked, do you want to enter more records? Yes, or no, as Y, or N. On output screen I type Y. It's stored in variable user choice. On line 38 is the cin.ignore function. It removes unwanted space in the input device buffer, which can create errors in the entry of characters, resulting in auto-skipping of the next keyboard entry. You can test it yourself and find the difference by removing or commenting line 38. Program control returns to top of the while loop and checks if user choice is small y or capital Y. It's small y, and so the while loop is once again executed. The getData function in E of count, or E of 1, is executed. For the employee name, I type in Paul Gallo. It's stored to the variable n of object E1. Then for the employee number, I type Q012. It's stored in variable roll_number of object E1. For salary, I type 48,000. It's stored in variable salary of object E1. Program control is back to main function, and then to line 35. Count is increased, and becomes 2. User is then prompted, do you want to enter more records? This time, I enter n for no. It's stored in the variable user choice. Once again on line 38, cin.ignore function clears the input buffer. Program control returns to top of while loop and checks if user choice is small y or capital Y. It is small n, and so the program control exits executing this while loop, and jumps to line 40. The employee information title is printed on output screen. Then using for loop, we display information stored in the objects by executing printData function of object E0, and then that of E1. So in this program, you learn to tackle object arrays quite effortlessly. We will next store the object array into a file, and then read them from the file.